Hello everyone, my name is Rahul Mishra. Today we will see the complex polynomial equation. That is the polynomial equation having the coefficients of the polynomial are coefficients of the polynomial are complex. Okay. For example, let's say any polynomial equation. Let's say a n x to the power n plus a n minus 1 x n minus 1 plus a n minus 2 x x n minus 2 up to, let's say, a 1 x plus a naught is equal to 0. In fact, even though I am writing x, so x can be any number. It may be complex, it may be real. So in general, if you're talking about the complex polynomial equation, we write like this: a n z n plus a n minus 1 z n minus 1 plus a n minus 2 z n minus 2 a 1 z plus a naught is equal to 0. So this is exactly same as the, so basically this is exactly same as your real polynomial, but only difference is the coefficients. In case of complex polynomial, we have the these coefficients are these coefficients, they are the complex number. That's the interesting thing. They are complex number. Okay. And the solution is exactly same. The method of solution is valid. Okay, the same as in the real polynomial. Let's say we have z1 z2 z3 up to zn are roots. Let's say roots of polynomial equation. Okay, let's see the roots of the polynomial equation. Then we can write a n z to the power n plus a n minus 1 z n minus 1 up to a1 z plus a naught is a n z minus z1 z minus z2 up to z minus z1, where z1 z2 z3 are the roots of a this complex polynomial. Okay, so the method of solution is valid, and important thing is the same. Just like in the real polynomial, we have the method of solution, well, that is degree. So degree, whatever the degree of this polynomial is same as the roots of equation. Let's see this as the n degree polynomial, complex polynomial, then it will have a n roots. Okay. Now let's talk about the something called a square root. That is also very much important. So in understanding the polynomial, let's see how to find the square root of a complex number. Okay, square root of complex number. So to understanding the polynomial, let's study the square root of complex number. And in square root, one should also know that this particular AB is equal to root A root B. Obviously here A and B are real number, is valid if, in condition, if at least one of A and B is non-negative. Okay, at least one of AB is non. That means this is valid if A is positive and B is positive. Also it is valid if A is positive but B is negative. It is also valid when A is negative and B is positive. But the important thing is this is not valid if A is negative and B is negative both. So the condition is this is not valid. Sorry. So basically the thing is this particular things is not valid. This is important things. Okay, this is not valid. This is wrong. This is valid. This is valid. This is valid, but this is not valid. Okay, and we can check it. Why I am telling that? See, if let's say we have the root 2 and let's say minus 3 is equal to root minus 6, perfectly fine. But if I write let's say example, root of -1 and root of -1. Clearly it is -1 into -1. This is root of 1. But if I talk about what is root of -1, root of -1 is I, and this is root of -1 is I. So I into I is I square, that is -1. So clearly this is -1 and this is 1. Then they are not equal. So which is correct one? Obviously the way we are following this root of a and b is equal to root ab is not valid. Why? Because both a and b is negative here, whereas the correct form is this one. This is the correct form. Okay, ठीक है. So let's try to find the one example of find the square root. Let's say a question is, let's say we find the square root of any complex number. Okay, so let's find the square root of any complex. Let's say any a plus ib, we have to find the square root of a plus ib. How do we find? We'll go with one example, and that is general for finding square root of any complex number. We'll follow the general rule. Okay, so let's say we have z is equal to 3 plus 4i. We have to find the square root of 3 plus 4i. So how do we find the steps is common. So first we'll take the square. Z square is 3 plus 4i. This is square. See, this equation 1 and equation 2, both are same. 1 and 2 are same. Okay, so let's say we assume that the z is equal to x plus iy. So what is x plus iy? It is nothing but the square root of 3 plus 4i. So what I will do, I will in the second step I will square z. So x plus iy square is equal to 3 plus 4i. So it's squaring. We know that x square plus y square is x square minus y square plus 2i xy is equals to 3 plus 4i. Now comparing the real and the imaginary part, we will get x square minus y square is equal to 3 and 2xy is equals to 4. Okay, so let's solve this. How do we solve this? See, we have to solve this equation. If you have to solve this equation, x square minus y square, it was 3 and 2xy 4. So x square minus y is equal to 3 and 2xy is equals to 4. We have to solve this equation. How do we solve it? Now to solve this one, see, we got a square minus b square is this. If anyhow we get a square plus b square, see, the usual step is, if we are somewhere given a plus b is some value, let's say 4. If anyhow I can get a minus b is equal, let's say some value 6, then we can easily find a and b. So here also x square minus y square is equal to 3 is given. If anyhow I can get x square plus y square, then our job is done. So what I will do, I will do this one, x square plus y square square. So what is this one? X square plus y square is nothing but, we know that x square minus y square square. So I think you know that the a plus b whole square is equal to a minus b square, because a square plus b square plus 2ab. This is a square plus b square minus 2ab. So I have to add a square minus b square plus 4ab. Okay, 4ab. Same here we apply. X square plus y square is equal to x square minus y square plus 4ab. So 4x square y square. Okay, so now we'll solving this one. So we get x square plus y square this square is nothing but x square minus square is 3, 9 plus 4x square. So this is nothing but 2xy whole square, that is 16. So that is 25. So I will get x square plus y square is equal to plus minus 5. Mind it, x square plus y square is equal to 5 and x square plus y square to minus 5. See, x, even though we are solving a complex number, but this x and y are purely real number. Okay, y is the imaginary part. So we should know that this y is the imaginary part, x is the real part. Okay, so x square plus y square is essentially a real, and real square of any sum of two real number is always a positive, whereas in this case given value is minus 5. So minus 5 is not possible, so we'll discard this value. So essentially we will discard this value. Only value possible is x square plus y square is equal to 5. Now we have x square minus y square is equal to 3 and x square plus y square is equal to 5. So solving this 2x square 5 days, so x square is equal to 4. So I will get x is equal to plus minus 2. Similarly I will get y square is equal to 1. So y is equal to plus minus 1. Okay, so we are getting 4 answers. So essentially what we said, z is equal to x plus iy, we started with the square root of 3 plus 4i. Okay, so we have x value is, we got x value as plus minus 2 and y is plus minus 2. So x is plus minus 2 and y is plus minus 1. Okay, so that means what? That means there are 4 combinations possible. So it appears that it has 4 answers. It appears that is 4 answer. No? Taking what are the possibilities? 4 answer means either 2 plus I or 2 minus I or minus 2 plus I and minus 2 minus. It appears that there is a 4 answer. But observe that, see, if you are solving z is equal to x plus iy, so essentially what does it mean? It means z square is equal to 3 plus 4i. So z square is equal to 3 plus 4i means it's a quadratic. Okay, second degree polynomial. So what it means? It's a second degree polynomial. It's a second degree polynomial. Since it's a second degree polynomial, it should have only 2 roots. Second degree polynomial means only 2 roots. Only 2 roots. So how do we satisfy which are 2 things? Because the condition is, even though we have x plus 2, see, if you observe that basically we have conditions are this one, x square minus y. So we can see that the conditions are x square minus y square is equal to 3 and 2xy is equal to 4. So we have these 2 conditions are there. So we have x square minus y is equal to 3, x square y is equal to 5 and 2xy is equals to 4. We got 2xy 4. Now you observe that what does it mean? This is the critical condition. xy, or let's say, see, using this we have the x as a plus minus 2 and y is equals to plus minus 1. But using this we can have a x y is equals to 2. That means right hand side is positive. So either both x is y is positive or both x y is negative. So only possibilities both are positive, that is 2 plus I, or we have x is equal to minus 2 minus I. Got it? That is, it has only 2 roots. So now we can say that the 3 plus 4 I has 2 values. Either we can say plus minus 2 plus I. It's something similar to if I say what is root 4. Achha, by the way, root root 4 is 2, it's not plus minus 2. See, if I say x square is equal to 4, then x has a plus minus 2, but someone say what is root 4, it has just a 2. Minus 2 is wrong, only plus 2 is answer. Got it? So this is how we make this take the square root, and using the concept of polynomial. Let's take some of the very good examples of the polynomial, and that will help you to solve some of the problems. Okay, so the question is, so let's say we have this question. We have to find the m, such m belongs to real number for which the equation z cube plus 3 plus I z square minus 3z minus m plus I 0 has at least one root. At least one root. But there is a one at least one root. In fact, better at least one real root. The better question will be at least one real root. Okay, now whenever you solve any equation, the approach is pretty easy. So whatever given condition is fine, the approach is simple. We substitute z is equal to, let's say, x plus iy, and then we compare the real and imaginary part on both sides. Then we compare real and imaginary part. Compare real and imaginary part of left hand side and right hand. This is the approach to solve the problem. So in this case, since it is given that this particular equation has one real root, it is given that has one real root. Okay, at least one real root. At least means cubic is there. There are three roots. Either that one is real, another is the complex conjugate, but at least one real is there. So assuming that one real root, so let's say let us assume z is equal to k, where k belongs to real. Okay, so that is one real root. So that is given. That is, equation has one real root. Equation has real root of since why I assume, because question has given that one real root. Okay, since it's real root, it should satisfy the equation. So satisfying in the equation, we'll get z cube. So k cube plus 3 plus I k square minus 3k minus m plus I is equal to 0. Now we have assumed z as a real. Okay, so let's break the real and imaginary part. So k cube plus 3k square minus 3k minus m, this is the real part, plus imaginary part is k square and minus I, so k square minus 1. Okay, now we will solve this equation. So real and imaginary part, we will copy these things and these things. So the real part, comparing real and imaginary part. Okay, so comparing real and imaginary part. So we have k cube plus 3k cube plus 3k square minus 3k minus m is 0, and k square minus 1 0. So comparing real and imaginary part, I will get k cube plus 3k square minus 3k minus m is 0, real part, and imaginary part is k square minus 1 is 0. So it will give the value of k is plus minus 1. So so there's two equations, 1 and let's say 2, and 2 is nothing but the roots. So if I assume that the k is equal to 1, if k is equal to 1, then from first I can say that 1 cube plus 3 cube, so 1 plus 3 minus 3 minus m is equal to 0. So I will get m is equal to 1. This is value we got if k is equal to 1. Similarly, if k is equals to minus 1, Then from first we can say that the 1 minus 1, so cube minus 1 plus 3 and plus 3 minus m is equal to 0. So m is equal to 5. So this is when at least one, so that at least k, they said at least one real root. So assuming k is a real root, so ultimately you need not to check for other roots, because ultimately m is a constant. M is constant is valid even though the roots is real, imaginary, or what doesn't matter. It's not that if you the roots are non-real then the value of m will be changed. M will not be changed because m is a real root. M is a constant. It will be independent of what root it has. So since it is given that at least one real root, so we assume real root and we compare real and imaginary part and we got the answer. Okay. Okay. Now let's take one more example from the polynomial point. So let's say we have any equation fx is equal to x to the power 4 minus 4x cube plus 4x square plus 9x plus 44. Now if I ask you find the value of f of 3 plus 2i, if I have to find the value of 3 plus 2i, okay, so how do you find? So 3 plus 2i will substitute and we find 4, but the problem is it will be little bit lengthy if I substitute, because 3 plus 2i to the power 4, either we have to use the binomial theorem to simplify or we have to multiply it 4 times. Okay, so so what we can do, the one observation is there. Observation is that since the coefficients, see, if the coefficient of polynomial, since the coefficient of polynomial is real, the roots exist in conjugate pair. That means if a plus ib is one root, then a minus ib will be other root. Got it? So if coefficients of polynomial is real, then obviously one of the root is complex, the other root will be complex conjugate. Got it? So now it's easy. Why? See, they ask me find 3 plus 2i. There's one interesting thing. Sometimes it is asked to find there are other way also. I will explain you. But first, whenever you get the problem of like this, try to first convert this polynomial in terms of product of two polynomials. I will explain you how. So clearly here a plus ib is the roots. So I can say what are the roots? One root is x minus 3 plus 2i. Other root will be x minus 3 minus 2i. Conjugate pair, complex conjugate. So what does it mean? So essentially one root. So what is the, so these are the roots. So what is the quadratic equation? We can say that what is the sum of roots? Okay. See, sum of roots alpha plus beta. Sum of roots is anyway 3 plus 2i, 3 minus 2 is 6. And what is the product of roots? Product of roots is 3 3 is 9 plus 4. So 9 plus 4 is equal to 13. So understand what is the corresponding equation, corresponding second degree equation having roots 3 plus 2i and 3 minus 2i. That is x square minus sum of roots plus product of roots. This is the equation. This particular equation has a root 3 plus 2i and 3 minus 2i. Okay, now what does it mean? It means that any function fx, x to the power 4 minus 4x cube plus 4x square plus 9x plus 44 is nothing but some coefficient divided by x square. So basically this particular equation can be written in terms of the x square minus 6x13. Why? Because this equation has a root 3 plus 2i and 3 minus 2i, and this equation has also a root 3 plus 2i and 3 minus 2i. Got it? So we'll write like this: x square minus 6x plus 13 plus remainder. This is the remainder. Okay, so this is the remainder. This is the remainder. So what does, if I ask you what is the value of 3 plus 2i, what does 3 plus 2i means? 3 plus 2i means, obviously if I substitute here, I will substitute here also. Substitute here also 3 plus 2i. So 3 plus 2i, substituting, this has a root. We already know that this has root 3 plus minus 2i. That means if I substitute on this equation, they become 0. So q into 0 plus remainder. So we get the remainder. So what is remainder here? Clearly remainder here is when this x square minus 4x cube plus 4 square plus 9x plus 44 divided by x square minus 6x plus 13, we get the remainder. Okay. Okay. So let's find. So how do we get the remainder? We will divide x to the power 4 minus 4x cube plus 4x square plus 9x plus 44 if divided by this one is this one, x square minus 6x plus 13. So we'll solve it. So we'll get the x square x to the power 4 minus 6x cube plus 13x square. So I will subtract it. I will get 0 plus 2x cube minus 9 9x square plus 9x, and that will be x square plus 2x. So plus 2x means 2x cube minus 12 x square 26 plus 26x. Again we'll solve. See, we go on solving, ultimately we get the remainder as a, see, this is the second degree polynomial, so its remainder should be either constant or the first degree polynomial. So we'll get the remainder as a x plus, okay, let's solve again. So this will be 0 3x square 26 में 9 गया plus 16 26 10 16 9 17x. So again I will add here 3. So 3x square 6 3 ja 18 minus 18x 13 3 ja 13 3 ja 39. Okay, acha, by the way, here also 44 is there, this 44 is there, so I will subtract it. I will get 0, this will be 17x minus, so minus, this is minus, okay, this is minus 20x, this is minus 18x, so I will get x and this will be minus, so 44x plus 5. So this is the remainder. Why this is the remainder? Because this is the second degree, so its remainder should be in first degree. So its answer is, so essentially in this case I will get the f2 plus 3i is x plus 5. Got it? Let's solve one more problem. let's say solve this equation. Solve z square minus I z minus 1 is 0. Okay. So what are the steps? As we done, the steps is straightforward. If you solve any polynomial equation, first step is assume z is equal to x plus iy, and then basically we have to solve. That means we have to find the z means x and y. Z is x plus iy, and second, substitute and compare real and imaginary part. Substitute x plus iy in equation and simplify, substitute, and then again obviously we will simplify, and then we will compare real and imaginary part, and then solve to get the x and y. Solve to get x and y. X and y means the value of z, that is z. So we need to find, solve means finding z. Okay, so these are the common steps we use here. So let's discuss how to solve this equation again. So we already explained the steps. So z square minus I z bar minus 1 is equal to 0. I have to solve this equation. So solve, let's say z is equal to x plus iy. So what is z square? Z square is x square minus y square plus 2ixy, and z bar is x minus iy. So substituting here, substituting in this equation, I will get x square minus y square plus 2ixy. This is the z square part minus I times z bar. Z bar means x minus iy minus 1 0. So now we'll write real and imaginary part, and then we compare. So what is the real part? X square okay, so we have x square minus y square, and here minus xy minus iy, so it will multiply it. So what will get? Minus I square plus y and minus 1 minus this, the real part plus imaginary part is I 2xy, and this is minus ix. So minus x is equal to 0. Now we'll compare real and imaginary part. So we have to solve by saying these two equations: x square minus y square plus y minus 1 is 0, and 2xy minus x is equal to 0. Okay, see, for solving this, first I will get x common, so 2y minus 1 is 0. That means either x is equal to 0 or y is equal to 1 by 2. Okay, and then we'll substitute here and we'll, so try to solve x square minus y. So we can have x has two values, either 0 and y is equals to half, and the second equation we have the second x square minus y square minus plus 1 minus 1 0. So I will set the x square minus y square minus y minus 1 0. I will take the, let's say, case 1. I will take x is equal to 0. If I take x is equal to 0, I will get y square minus y minus 1 is 0. Okay, so y square minus 1 is 0, but problem, you understand, this discriminant is negative. Discriminant is b square. We'll get this one. If I substitute minus y square, minus square minus, so I will get y square plus y plus 1 is 0. So discriminant is 1 minus 4, which is negative. Since discriminant is negative, that means y is a non-real. Y is non-real. Okay, but if you observe in the question, not question general, if someone says z is equal to x plus iy, so clearly x and y belongs to real number. Got it? So clearly here y is non-real, so that means this is not possible. So we'll take the case 2. Case 2 will take y is equals to 1 by 2. Y is equal to 1 by 2, substituting, so I will get x square minus 1 by 2, 1, so I will substitute here y square minus y minus 1. 1 by 4 minus 1 by 2 minus 1 is 0. So I will get x is equal to x square is equal to 4. So 7 by 4, or x is equals to plus minus root 7 by 4. Okay, so what is z? So z is we have taken, this is not considered x, so x is either we can say plus 7 by 4 root and plus I y, that is half, or we can have a minus root 7 by 4 plus I 1 by 2. Got it? So this is how we can find these two solutions. Okay. See, this is here the problem is z square minus I z bar minus 1 0. But if let's say I take a very basic example, if I ask you solve this quadratic equation z square minus I z minus 1 0. Now solving this, it is exactly same as the quadratic equation. Got it? So see this equation, again note down this part. See, the thing is ax square plus bx plus c 0. Here a, b, c either real or imaginary, doesn't matter. The solution, we can always apply the Sridharacharya rule or the quadratic formula, that is minus b plus minus root b square minus 4ac upon 2a. This is always valid whether the coefficient abc is real or imaginary. So same way here we will apply, and solving will solve. What is z? So z will be minus b, that is minus b means I plus minus root b square I square minus 4ac 4 1 c upon 2a. So it will be I plus minus root, this is minus 1 plus 4 upon 2, or will get I plus minus 4 root 3. So root 3 by 2. This is the solution of this equation. Okay. See, let's take one more polynomial equation. Let's say if I have to solve this equation, that is z cube minus 2z plus 1 is equal to 0. See, this is also exactly same we will solve. By the way, this is like a simple polynomial equation, okay, because the coefficients are real, so it doesn't matter. But if I want to solve, there is no direct formula available, so we such kind of polynomial which is higher than 2, we usual approach is use hit and trial. There is some general approach, but usual approach is use the hit and trial. Okay, so we can see that the z is equal to 1 satisfies. If I take z is equal to 1, I get 1 minus 2 plus 1 is equal to 0. So z is equal to 1 is the solution. As soon as we get z is equal to 1, we can directly say z minus 1 and other part is equal to this, convert into quadratic, and we can use the what is called the, if you want to coefficient this, I can use synthetic division. So synthetic division, z cube has a coefficient 1, z square has coefficient 0, z has a minus 2 plus 1. Then what we'll do, we have the z is equal to 1. So I will take it here 1, we multiply 1, put it here 1. Then 1 plus 0 is 1, then again 1 I multiply here, so 1 plus 1 1. So I will take here 1. then again 1 multiply 1 here, so minus 1, again this minus 1 multiply with minus 1, it will be minus 1, 0. So we get 1 1 and minus 1, the coefficient will be x square plus x minus 1. Okay, so the equation will have what are the roots, we'll not write x, we write the z because we are using here z. So this is nothing but z square plus z minus 1. Now we can solve it. So z is equal to 1 by hit and trial, and second by quadratic equation. So z means minus 1 plus root b square. B square means 1 plus 4 upon 2. That means minus 1 plus minus root 5 upon 2. So we have the solution of cubic is first root is this, and second and third root is this one. Got it? So this is how we solve the polynomial. So other polynomial equation we can use either hit and trial or we compare real. So basically if we want to solve any polynomial equation, so any polynomial equation, any a n x n, let's say I write z here, so zn plus a n minus 1 zn minus 1 plus a n minus 2 z n minus 2 up to, let's say, a naught is equal to 0. So the one of the approach is you substitute z is equal to x plus iy, and x and y is assumed to be real. That is the important thing. Second step is substitute in equation, in polynomial equation, and then we simplify this thing, and fourth we compare real and imaginary part. Compare real and imaginary part, then solve the equations. Solve equation in x and y. We get the equation x y, solve, and we get x y. X y is nothing but the solution. Okay. Okay. So I am ending the class here. So thank you everyone.